Hello, my name is Karen Chauvin, and today I'll be presenting for you a way of reducing project risks through thinking about sustainability and systems integration. I am the CEO and founder of Enviro Integration Strategies. I'm also the chair of the Environmental and Social Responsibility Society, and I'm a member of the Global Action on Tailings with the Global Mineral Professionals Alliance. And so, as you might get from the titles, I am very much interested in reducing waste management risks of mining projects. I'm looking at ways of creating value from wastes and the infrastructure that we utilize through mining processes, and the elimination of waste altogether wherever possible. And of course, integrating sustainability into all of our practices of mining developments so that we can minimize those risks and long-term impacts. So this is why I've chosen this topic. So I wanted to get into a bit of project performance statistics, because in metals and mining and in oil and gas, we have significant problems with our projects. So a lot of projects have cost overruns, 69% on average, and anywhere from 50 to 73% on schedule delays. And when we actually do have cost overruns, it can be anywhere from up to 80% I've seen, but I've seen also in the plus 200 or 300% category. So they can be very significant. And the studies have shown that when we think about the delays associated with these projects and the costs associated with those delays, up to 73% of them are caused by non-technical issues. These are risks that are associated with failure to engage and communicate with the folks on our team and with people who might influence the project. There's misalignment on objectives. What are we actually trying to do? We have problems with capturing information and putting it in a place where everybody has access to it to see what's going on. And exchanges of that information or handover of information from one team to the next can be a challenge. And also, because of the length of the projects in mining, there are often problems with changes in teams and personnel over time. And we miss those links when we transition. Some of the biggest issues that we face in mining and any industrial development really include things like mistrust of our designers, of our owners, of our regulators, and people really concerned about that ESG performance, whereas ESG is the environment, social, and governance performance. It's really hard for people to forget the past practices that we have, and we continue to have failures of our tailings and waste infrastructure. We have disturbed lands and impacts that haven't been addressed from past practices. There's lots of messes left behind, abandoned sites that we haven't dealt with. And there's been a lot of mistreatment of communities in different parts of the world and broken promises as well. So, we have all these trust issues and things that get in our way of actually doing the work that we need to do. But more importantly, there are things that we should be thinking of to address right from the start. And mining just, there's a lot of good companies doing good things, but we're still learning and a lot more needs to be done. So here are some statistics just to show in terms of tailings failure, that our challenges, while we have improved our performance over the last 30 years, you can see the bars stacked up. These are failures of tailings dams. And you can see that we cut the rate in half about 30 years ago, but that we still have quite a few happening per decade. And the red lines that you see are trends of the severity of the failures that are happening. So even though we've cut those failures down, the number that are having very serious consequences are continuing to climb. And that is because As we move over in time, the dams that we're building are much higher, they're much longer, bigger, they're containing more tailings than they used to because our grades are lower. And there's so many different complicating factors, but the problem has not gone away. Now, in a mining project, there are many, many life cycle stages. And so you can see, I've kind of laid them out here, but people, when they think about the life cycle of mining, they often think about the operations and closure, and maybe some post-closure. But really what we're thinking about all the way back through the project initiation, once we decide we want to go and look at a site, we've got all the exploration that happens at the beginning, the development, the appraisals that happen. So we're on site quite a long time to do that. We have all these evaluation stages and design stages that we have to go through. And then we finally have our environmental assessment process before we can even think about development and then operation closure and post-closure. So there's a lot of stages, and they do take a number of years to progress. So this is the stage here where we can't do anything on the ground in terms of development until we've gotten our environmental assessment approval. And this is another stage where even though we've gotten our assessment approval, we won't get our operating license until we've actually shown that we've developed it in a fashion that aligns with the EA. And also to show, that we have operating processes and procedures in place ready to go into operations. So there's some different stages of permitting that have to happen before we can actually move forward. Then we get to the longer term phase of closure. We actually do have to do a second environmental assessment, usually at that stage, to really refine the design for closure and what we're going to do at that stage before we can actually implement some of those measures. So basically, when we're talking about projects, we want to ensure that we've addressed some goals. So when we're in the pre-development stage, some of those goals might look like gaining external stakeholder support, right? So we're talking about our communities here and our regulators. We need to make sure that they support our project appropriately, because this facilitates us getting those approvals in a more timely fashion. There's less resistance to what we want to do if they're on board with what we want to do. And of course, when we're thinking about all the design sequences, we need to look at our cost of development, the schedule, and the quality that we're going to build to. We want to make sure we're going to meet all of that within those early stages. Now, on the development, operations, and closure stages, we want to make sure that we're maintaining good relations and social license to operate, because we have disagreements that can shut us down. If we have poor performance, that can shut us down, and incidents can be very devastating as well. So in order to do this, to achieve these goals, we really need to be thinking about engaging our stakeholders. We need to listen to know what they want and expect, and we need to determine how they can and should be involved with different decisions that are being made throughout the process, and how they'd like to be involved with the development of the project, whether it be through jobs or contracts. Perhaps they want some things otherwise to be done separate from the project. There can be many things. We also need to really understand our project. We need to know what are the conditions of the site that will impact the project itself, so that we're designing appropriately to work well within that environment. We need to think about the potential impacts to the local communities and the people that are around the project. And then we also need to think about the impacts of our project on the environment, so that we can balance all of these perspectives and make sure we put in the best solutions, which means often we need to innovate and bring in new strategies and technologies to do so. But We tend as engineers and project managers to create our own challenges. We have a lot of behaviors and habits within industry, and in particular, silos. We like to break off into our own disciplines, into different levels of seniority, and we often don't talk to each other. This is a huge challenge, and it's something that we need to get past. We need to get past also our comfort levels of not changing anything. We always default to what we know best and avoid the risk of taking in new perspectives and new ways of doing things. But really, that's the only way we can progress and innovate and do things in a better way. So we need to get beyond that. And we need to stop working just to get something done, right? We don't need to take off and go into our corner to work alone just to get through and get something done. We actually need to have those conversations and make sure we're addressing challenges along the way. The challenges that I'm talking about, you can see how they can lead from one thing to the next. It's kind of a compounding effect. If we have silos, that means we have poor communications and misunderstandings happening. They're not being addressed. We may be missing some key risks that we should be taking care of if we haven't talked to the right people, or if we haven't engaged the right people at all. Sometimes we've just been a poor engagement levels, and sometimes we completely miss the mark. When those things happen, that's when we can get this like cost overruns and delays, because we end up finding things that we should have taken care of. And so we need to change our scope and do additional work and add to or change the work that we were already done. So we can cause rework, which is very costly and time consuming. All of these things, adding these things up, can lead to an insufficient budget. It can lead to loss of support for the project. It can lead to opposition and ultimately project cancellation. Every mine company's biggest nightmare is to have done all this work and result in a no-go project, something that isn't going to happen after they've spent all this time and money pushing it forward. So what do we do about it? First, we really need to understand who our stakeholders are. There are so many different categories of stakeholders that could be involved with our project. Whether they're directly involved in the decision-making or not is something that we determine along the way, but we do need to make sure that anybody who has a potential influence on our project, we've identified anybody who has the potential to be impacted by our project, whether they're wanting to be involved or not, they need to be engaged as well. And we need to think about both the communities as well as potential operators, future owners, contractors that might be involved, because all of them may have a good input on how to make your project better or things that might cause you some challenges. So what do? We start with the end. We want to think about what's that legacy going to be? How do we want the site to perform? How do we not want it to perform? What do we want to make sure never happens? What do we want to create? Sometimes the communities have different ideas than what we might put in place. What do the local communities want and need? And how will we meet all of these needs? We have to think about all of these things up front. What's the preference? What if we find out that the preference is not to return the land to pre-mining land use? What about other uses of the land and infrastructure? What other things might bring long-term economic prosperity to a region? Okay. Now, the next thing I want to show you, of course, we want to think about the things we don't want to happen. We want to make sure we're doing everything we can to prevent failures within our design up front. Now, I'm going to pause talking here and I'm going to show you a video clip because I think it's critical that each and every one of you see the devastating consequences of failure. So if you just give me a minute here, I'll find that. Okay. So this is a recording of a failure that happened just 2 years ago now, where we just passed the anniversary, and over 270 people were killed and or have their bodies have never been found. Record setting on the scales of failures, and I believe they just put through that there will be a $10 billion overall fines and financial consequences of this failure to the company. So let me just walk you through this. It's really hard to watch, so bear with me. Okay, here we go. Now you can see the scale of this dam, and that the entire thing collapsed all at once without warning. There were people working on the dam, which you'll see in just a few minutes. This isn't a typical dam failure scenario, but it is possible on many levels. You can see all the people on the dam running, nowhere to go. Further people on the side managed to escape, but we're watching their team disappear. Now this failure happened at a point in time when all of the crews from the mine were going on lunch break or already in the lunch rooms, and their building for the lunches and their offices were all directly in the line of fire downstream of this dam. I'm going to jump ahead a little bit here to catch some more downstream effects. So this is the ore sorting and packaging area. It's on a bit of a ridge aside from the valley where most of the flow is going. There's some people up there. You can see when they zoom out. Some people that are up in the offices and working space there. Their area is surrounded by a train system to be loading those materials out. And what you'll see here is the flow starting to come into this area. And it's quite obvious that that is their exit, only exit is towards the flow. And the couple of individuals who are up there are basically surrounded and have no escape as well. Now, I will say that I learned after the fact that some of the individuals in this area did survive. I'm not really sure how, but devastating. All right, I'm gonna stop that here and come back to recording. All right, so as you can see, prevention first by all measures, very critical. So the other things I want you to think about in terms of the long-term outcomes, what do we want to have here? There are a lot of things happening around the world in different places about how we can actually reuse mining infrastructure and disturb lands for other purposes. And some of these you could do ongoing during operations. There are some examples in Canada actually of that happening, but these are some really interesting things. So in a place, a closed mine in Finland, I think, they have converted their underground caverns into individual labs and testing facilities for all kinds of interesting things. So there's like edible insects being grown underground because it's more like a controlled climate, like a greenhouse that you can set up to whichever way you need for your experiments and work. There's greenhouses, there's rescue training, there's all kinds of interesting things. And they're also setting up spaces for offices and labs and other projects. They also have opportunities for the use of both underground and surface for energy management. So for an underground, you might have stored energy by pooling water at the surface and then dropping it to collect that energy and then pumping it back up in a continuous loop. You might have similar types of strategies from pit to pit, depending on the depths that you have within your pit and the differences in elevation. But you can also use that disturbed land for solar panel farms and wind farms. And then this top picture here is actually a neuro network lab for black matter research, doing experiments underground where they are not impacted by the solar energy coming in. So some interesting things like that. There's also thinking about redevelopment of the land into more tourism related things. There's golf courses, gardens. This is a picture of the Bouchard Gardens, long ago converted into these beautiful gardens from an old quarry. And then underground, there's quite a few different examples of sort of cross-country extreme sport type of applications in mining environments, both above ground and underground. So that's kind of a neat concept, some zip lining across pits and things like that. And also, this picture of the ski slope is actually on a landfill, but very, very applicable to waste rock piles and formulating different landforms into trails and hiking trails and skiing and such things. So there's lots of different opportunities depending on the region that you're in and the presence of communities in the nearby area. So what do we need to actually do to enable something like this? We need to change our strategy. We need to pick what it is that we want to do for this end of life of the mine, and think about that at the very beginning when we're thinking about the objectives of what do we want to develop. So we're not just thinking about what do we want to do for the mine itself, but also what we want to do at the end of the life. If we set those criteria and objectives at the beginning, we can do the studies that are necessary to remove any barriers that might prevent it from happening or cause risks that we need to address. And once we can remove all those things, it makes it much easier to get approval for environmental assessment process, both from the regulators and from our external stakeholders, because now they're seeing benefits that come back to the communities. And then we can move through the stages of, the final design and development operations, and then transitioning progressively into these other uses at the end. Some of the things that we need to do on the team side to make this happen are to really make sure that we're very aligned on what those objectives are. We really need to understand how this impacts the things that we need to do as part of our design work for the project. We need to know what the constraints are and how different systems work together. We need to address all these barriers, particularly the environmental and social aspects first. and addressing all of those different stakeholders' desires that need to work into the project. And then we need to actually co-design those processes to get there. So we make sure that we've addressed all of the intricacies and the things that intertwine for these complex and very large-scale projects. Some of the work that I do looks to increase the visibility and understanding between teams. So the more visible work is, the more visible that everyone's different ideas and ongoing work is, the easier it is to start to see where there's holes in the picture or where people are maybe duplicating efforts. So we need to be working together and have that visibility, have a way of sharing information so everyone has access to see what it is that we're working towards. We need to understand that there are also times when we work apart within the silos so that we can just get things done once we've made those bigger decisions on what it is. And we need to think about sometimes some teams can get work done quicker than others, and some are dependent on doing work out in the field and the seasons and things like that. So we need to be thinking about the different time scales and horizons of how work comes together and what things need to be started earlier than others. And the differing needs and wants. So what I mean by that is when one team is doing work, they may need some information earlier from another team before they complete their analysis. So give you an example that in order to develop, say, the processing plant, they need to have complete the testing of the like the pilot testing of the process. But a team that's working on assessing the risks of, say, the waste materials or waste rock piles, they may just need the data, the raw data of what is the mineralogy that was in the ore body, and then some field data on water management and the water levels and climate, things like that. So different teams need different pieces of information, but the team who's collecting or say doing the pilot work, they need some of the same data, but there's just different intersections that things work together. So we just need to understand those and who needs what information and when, so that we can move that along. Now, the last thing I want to go through is just we really need to think more holistically about the system and also consider the fact that there are several life cycle stages and different impacts or risks at different stages. So we want to think about, sustainable design and operation, which really impacts like when we're actually operating, how is it that we're going to minimize impacts to the environment or people. So we're thinking about safer reagents, less toxic things, fewer reagents, thinking about the efficiency of our equipment and how much we can maximize the resources, the reuse, so say water and maybe even waste streams. The designing for closure, we're thinking about that long-term aspect. How can we minimize impacts in the long term? What are we leaving behind? How can we maximize the value of the waste? So by creating maybe some byproducts, and if we have to leave things behind, how can we make sure that they're inert, chemically inert, that they're compacted and stable, and that they're in their final landform so we can move through reclamation? And how do we make sure that what we leave behind is able to be passively managed? We don't want to have active, ongoing management in perpetuity. Sorry, wrong way. And then the last is sort of applying some lean thinking. And really lean is really about keeping the flow from stage to stage, the flow of materials, the flow of information, sort of maximizing that flow and minimizing like stops and starts and rehandling. So if you apply that to all of these things, you'll minimize risks, you'll minimize impacts to costs, and just make it a better system overall. So like an example is if we're gonna build a waste rock pile, often mine sites have, they've dumped these materials in one place and then they have to come back and then reslope them and regrade them before they can reclaim them. But if we think ahead in a lean fashion, we would make sure that we build it into the landform and bench it out the way that takes a much more, or minimizes the work of regrade that needs to happen at the end, so that we can progressively start to reclaim as well and not wait until the whole thing is finished. So that's just an example, but there are many different aspects to think about. Now, the last thing I want to bring up is that really this world is moving into more of a circular economy. And it's really having big impacts on how we might do things, what we might design differently. We have the ability to think big. Now, some people think about the things that are coming up front, that circularity means the elimination of mining. And that may be the case for smaller producers that have equipment that they can easily disassemble and reuse parts for. But we have to recall that they also have a growing population, and part of the challenges in meeting the SDGs overall means that we're moving everyone to social equality, a state of living that is equivalent for everyone. And that means more infrastructure, more buildings, more clean water, food. All of these things require mining products. And so the demand for mining is not diminishing. In fact, it's increasing. And even for renewable energy, there's a heavy load demand for particular metals to enable that. So the thing I want to take away from here is, yes, everything's moving towards circular economy. Mining needs to be a core part of that. But we would want to be thinking about, how do we do things better and how can we redesign our processes to actually make it happen? So, things like 3D printing and changing the products that we create, or taking waste and turning it into product are all beneficial to working in the circular economy. Now, the final things, project delivery mapping. This comes to the visibility piece. If we can clarify the processes and responsibilities of each discipline and what team is doing and how they're going to interact to exchange the right information at the right times, this keeps that communication open. It helps us stay on the same page. It helps us move the project forward in an efficient manner. And it makes sure that we have the right people involved for some of those core decisions that need to be made, so that we can reduce the risk of the delays on schedule and the cost overruns that I started out with. Now, some things that I haven't touched on yet, but do in fact cause challenges in projects, are the documentation of what's been done and the reasons why certain things have been designed the way they are, or that the management system in place is there for what reasons. We need to make sure that, because these operations have such a long life cycle and transition of team members and leadership and even buyouts into other companies, we need to ensure that it's clear what things were put in place to manage particular risks, why decisions were made, who was involved with those decisions in case we need to go back to them for something, what were the conditions around those decisions, so that if the conditions change, we have the ability to reflect on those and reassess those risks. We need to know what the controls are and why they're in place. So all of these things are critical. So documentation, so that we can ensure the understanding is clear for everyone involved and for those transitions. Some of the life cycle transitions that I would highlight are, moving from the construction phase to operation. Have we built what as-built reports are? Have we built what we actually designed? What changes were made in that process? Let's be clear. Have we changed something and introduced a risk that we missed that was supposed to be taken care of. OMS manuals, that's operations, maintenance, and surveillance manuals. If they're not complete, or you haven't documented those risks that are being managed through those controls, they're really not very useful. So we need to make sure that those are good. And the changes of personnel, if we've documented things well and have good communications during teams, when 1 or 2 people change on the team, it's much easier to get them up to speed. The other thing that can happen is moving into operations. If we haven't done the work well up front in understanding the operating conditions, when we go into operation, the design may fail because we didn't take the right things into account. So we want to be thinking about the people who are operating the plant, the folks who will be there managing the controls, so that if we've engaged them and they have previous experience on other operating sites, they can bring in that knowledge of things that we should be thinking about in the design phase, so that we don't run into these problems. And we always want to make sure that we've engaged all the right stakeholders, because we don't want to surprise them with new things that weren't communicated, which maybe they will impact their work or impact what they think about the project. So we need to be thinking ahead. And training is critical. So you can't put a system in place if you haven't trained the people who are going to be using that system well enough to make sure it works well. So, closing statements. Project success comes from early stakeholder engagement and alignment of all of those stakeholders. You need to know who to involve for sure. Clear communications, visuals, maybe using mapping to align everyone and help keep things live and in front of everyone as you move forward. Understanding the interdependencies and risks associated with those within your project complexity. And of course, then thinking through of the holistic process, being iterative and integrated with how you assess things, turning over ideas and figuring out the best solutions, being inclusive in that decision making, making sure you have the right people at the table when decisions are being made, so that it is an agreement and changes don't be made later on, and making sure you have good documentation and transfers. So I'll close with that. If anybody has any questions for me, feel free to reach out. My email is at the bottom of the slide. My website's there, my phone number. And just wish you well in your endeavors moving out into the world.